So in the previous class, we have discussed the thread forms and you have drawn the thread profiles of each threads. You have drawn for isometric thread, buttress thread, square thread and sellers thread, etc. So you have to remember the nomenclature and also the relations pertaining to the thread forms. And the next part is we will be moving with fasteners. And thread forms, again, they will give the same profiles what they have solved in the previous classes. The same thing they will give, only the change is the pitch they will change and other relations will remain the same. There is no change in other relations. So in this class, let us see what are fasteners. Fasteners, as the name itself indicates, fasteners. Fasteners means it is attached to with someone, attached with someone. So fasteners, here we are studying only temporary fasteners. Fasteners, that means it is fastened, it is attached to something. Here we are studying the temporary fasteners. There are several fasteners, temporary fasteners, permanent fasteners. Basically, an attachment we are defining. That attachment is nothing but, we will also call it as joint. So, temporary joint. Temporary fasteners are making temporary joints. The example for temporary joints is bolt and nut. The example for permanent joint is welding. So, whenever you want to remove the two materials, we need to distort, we need to destroy the workpiece. Basically, without distortion, we cannot remove the joint. Whereas the temporary fasteners, temporary joint, you can remove without any distortion. That is a flexibility of temporary joint. Also, apart from that, the load carrying capacity that will be changing from one joint to other joint, whereas for temporary joints the load carrying capacity is different, for permanent joint the load carrying capacity is different. So most of the cases we will be using bolt and nut, which it can be attached or detached. That is a flexibility of temporary joint. Let us define what are the fasteners. Temporary fasteners which holds the component through a medium of screw threads. How it holds, how it is attached. It is attached with the set of V-grooves located. In the previous class, we have seen thread forms. Thread forms are nothing but, on a cylindrical, you have a horizontal grooves. It is making a thread, external thread on bolt, internal thread and on nut. These two things will get attached. That is the flexibility of temporary fasteners. So temporary fasteners are those which holds the part through a medium of screw threads. Very important. Screw threads we have seen in detail in the previous sessions. The same thing we will be using here. So bolt and nut are the example for temporary fasteners. Whenever you want a joint, you can assemble the bolt and nut. If you don't want, you remove the bolt and nut, then the joint will get detached. Then stud. Stud is a cylindrical structure having thread on either sides. There is no head. Bolt without a head is stud. Bolt without a head is stud. So there is a flexibility of having two attachments on a cylindrical component on the either sides. That is nothing but stud. For the stud, you can have a nut, stud with lock nut. These are the examples for temporary fasteners. So let us see what are bolt and nuts in detail. As per Indian standards 1364 and 2002, we will be defining the conventions or standardization for bolts. And let us see what is bolt. Bolt is a solid cylinder. Bolt is a solid cylinder which has threads partially or fully as well as a shape of head with hexagon or square or octagon, and this shape of head is obtained by the process of forging. So this is a definition of bolt. A bolt is a cylinder having threads which are located partially or fully and the shape of head having hexagon or square or octagon, and this is obtained by the process of forging. So basically for a bolt we will be having an external thread, very important thing, thread, and also with a shape, So this is a bolt, and the conventions for the bolt is we will be defining the conventions of thread along with the length of the bolt. So for example, if you take a standard bolt, how to specify the bolt? Bolt is specified as per the external thread convention and length of the bolt. Say for example, M12 into 80. That is a convention for bolt. M12 represents the metric thread. M12 metric thread of 12 diameter, 12 mm diameter into 80. 80 means it is the length of the bolt. So like that we will specify the bolts. And remember, every bolt will have an external thread as well as a shape of head. When it comes to stud, there is no head. But bolt, it is having a head. You have to identify which type of head. Either it is square head or hexagonal head or octagonal head. The head is having some flexibility and it is giving a structure which is producing a less deflection. Because of head, the deflection of bolt is reduced. So it will avoid the overhanging feature of net. So if you imagine a bolt is having only thread on one side, if you just place a net over it, the structure may get inclined or deflected. In order to avoid the deflected, there is a counterweight on the other side, that is nothing but a head. So whenever we want to remove the bolt, we will be using the head, that is a flexibility. And we can remove the bolt by using net also. One side, if we use spanner, we can remove a net. One side for the bolt, if you use a spanner, we can remove the bolt. On either ways, we can have a removal attachment. So this is about bolt. Next, let us see what are net. A net is a cylindrical structure having some prisms like structures. So with an internal threads. So net can be defined as symmetrical or helix structure with halo prisms with internal thread. Symmetrical, hexagonal or halo prism structures with symmetrical head. It can have a square or hexagonal halo prisms. In order to remember the definitions, remove the word symmetrical, just square or hexagonal halo prisms. That is also okay. Halo prisms and with an internal thread. It is a nut. The specification of bolt, what you have seen, the specification of bolt is M12 into 80. So we will be specifying the thread as well as length. Whereas the specification of net is only the type of internal thread which is used. So directly we will give M12. That is the specification of net. So bolt, you know what is bolt, and then the definition of net also you have know. Mainly you have to remember a bolt is having an external thread along with a head which is square, hexagon or octagon. Net is a square or hexagonal halo prisms with internal thread. Just remember, bolt is having external thread, nut is having internal thread. Again, in the nut you can have a square shaped nut as well as hexagonal shaped nut as well as octagonal shaped nut. That is depending upon the design. And again, these two things combination, the combination of bolt and nut is called as screwed pair. A combination of bolt and nut is called as screwed pair because it is forming a pair of screws of threads. It is having an external thread and it is having an internal thread. Bolt is having an external thread, nut is having an internal thread. Because of the motion of internal thread and external thread, it is forming a screw pair. It is one of the pair which is used in kinematics. So, the flexibility of screwed pair is, again, it can be attached and detached. It leads to temporary joints. Because of nature of screwed pair, this is also called as screwed fasteners. Screwed fasteners. It is also called as threaded fasteners. There are several names for bolt and nut. We can call it as screwed fasteners, threaded fasteners, or temporary fasteners. So these are the different nomenclature of bolt and nut. And another important thing what you will be learning is a stud. What is a stud? A stud is a bolt without head. A stud is a bolt without head, but there are threads on either sides. But there are threads on either sides. So there is no head, but there is a thread. So if I represent a bolt and nut in a diagram, so this is a bolt. The bolt is having the diameter D and length L. Also it is having a head. Just I will assume it is having an hexagon head. I will tell you what is this lines. Here there are three faces. How you got three faces? If I write a side view of the bolt, I will be knowing what type of shape it is having. So this is a shape of the bolt which is having. This is having an hexagonal shape. So this hexagon shape you can see only inside view. So this face here it is visible. Again this face here it is visible, and this face it is visible. So you will be seeing three faces in a front view of hexagonal side. If you see a top view, you will be seeing only two faces. That is very important. Whenever the drawings is given, first always start your drawing with side view. Got it? And same thing, this is just a bolt. If I place a net, it should having a threaded, it should having an external thread. So just I will write like this. This line, hidden line indicates it is a thread. And this thread is meant for the net. Why thread is given? Because to have a net. So I will write the net here. This is a net. This is net and this is bolt, and this combination is bolt and nut. So very important to know what is bolt and what is nut and what is screwed pair. So this is bolt and nut assembly with the screwed pair, and this you have to write according to the dimension. For the question, first you have to understand which type of head is given. They will mention either it is a square head or it is a hexagonal head. No octagon head is there for your syllabus. You have to write either square or hexagon. Then after that you have to know what is the orientation of the bolt, how the bolt is placed. You can place a bolt in two ways. One is this way, it is placed on the corner. So this hexagon corner. Another combination is you can place the bolt in the side. So another combination is I will place this hexagon on a side. So this is how it looks. I am facing hexagon on the side, and also I need to know how many faces you will be looking in the top view. You will be looking only 2 faces. That I will write. Project this, project this. You will be looking only 2 faces, and again this is a bolt. Got it? This is an important thing you have to know. This is corner and this is side. Side or flat, or simply it is called as edge. 2 conditions. One is edge condition and another one is corner condition. So when you have a nut, then the nut is visible. You have to encircle this because the nut is visible. So this is the assembly of bolt and nut in 2 conditions. One is corner and another one is side or flat. Let us see what is a stud. Stud is a bolt without head. Just I will write a stud. This is a stud. There is no head, there is only a bolt, there is only a cylindrical portion, but this cylindrical portion will have threads on either sides. So this is a thread portion and this is another thread portion. This is a stud. So here there are 2 threads portions. In the between there is no thread, it is having only a shank. Shank is unthreaded portions of a component. So here also this part is called as shank. Shank is unthreaded portion left out, the distance between the threaded one and the head. So this is unthreaded part. So if you specify the length of the bolt will be given by threaded length plus unthreaded length. So using unthreaded length does not sound good in a drawing. So that length is nothing but it is a shank length. So total length of the bolt will be equal to thread length plus shank length. So this is a specification for the length. And this diameter will be mentioned. You will be knowing what is the diameter and what is the length. For knowing diameter and length, the rest of the calculations is based on the diameter. So this is how we will be specifying the bolt and nut, or we will be specifying the stud, or we will be specifying the threaded fasteners. And these things, when it comes to actual manufacturing drawing, I need to hold a bolt and nut, I need to tighten it, I need to loosen it. I will be using frequently. In automobile itself, you will be tightening your brakes. There is a nut. Like that, there are several things. Clutch plate, there is a nut, there is a screw. Sometimes what you will do is, you will be tightening in your hand only. So, if you use hand instead of spanner, the material of the bolt and nut or the material of the nut, sometimes if it is a mild steel, if it is having any sharp corners, then your hand will get worn out. In order to make a flexibility for a design, in order to make the surface smooth, what we will do is, we will be introducing a chamfer. We will be introducing a chamfer. This chamfer enables the bolt and nut in a smooth surfaces. Whenever we want a smooth surfaces, we need to avoid the sharp surfaces. That sharp surfaces is avoided using the chamfer angle. So say for example, here there is a sharp surface. I need to avoid that. How to avoid it? Yes, I need to give some either radius or I need to give some angle. I need to make a sharp edge into a smooth edge. So what I will do is, I will be smoothing this, I will be smoothing this like this, I will be smoothing all the things. So instead of giving radius to all corners, what I will do is, in the side view, I will be introducing some angle. This angle is 30 degree for the bolt. Similarly, this angle I will give. So because of that, what happens? I will be cutting at some radius, and this makes the surface smoothens. When you tighten or loosen the nut or bolt in your hand will not get worn out. That is the flexibility of the chamfer. You observe any sharp edges, there is no sharp edges practically. All the sharp edges are converted to a flat or round surfaces. Because of that, what happens? The flexibility of operator will be more. Operator can be easily handle that. Even the benches in the classrooms, they are flat. They are having some corners. Suppose if you walk fastly, what happens? Suppose if you collide with the bench, what happens? If there is a sharp edge on the bench, that will worn out your skin. Because of that blood, because of that many complexities will be there. So we need to avoid the sharp corners in manufacturing drawing. The answer for that is a chamfer. Usually the chamfer for the bolt, we will give 30 degree for the bolt. It will be ranging from 30 degree to 45 degree based on the length. If length is more, we need to give 45 degree sometimes. So standard we will be following for 30 degree for bolt, and at the end, bolt end, it will be giving 45 degree. So these are the standard conventions we will be using for bolt and nuts. Also bolt and nut, two components will be there in the combination. Whenever there is a relative motion between these two, the bolt should not worn out, the nut should not worn out. Again, if nut is worn out, replacing the nut cost will be more. If bolt is worn out, replacing the bolt is more cost. So in order to avoid, in order to give flexibility of movement, in order to resist the wear and tear of bolt and nut, we will be introducing a member in between bolt and nut which is having a smooth surface, and that is called as washer. Washer will be used. This washer will be avoiding the wear and tear of bolt and nut. So again, the washer is having some of the dimensions. We will be looking what exactly the dimension of washer in detail when I introduce that in a problem. So that is about a washer. Usually what happens in bolt and nut, the bolt and nuts are removed, attached and detached with the help of a spanner. The spanner has to make a proper contact with the bolt and nut. If you take a stud has to be tightened. You have seen the nut, rear wheel or front wheel nut, you have seen. How to tighten it? Yes, it is tightened by using a spanner. That spanner should have fit to the nut. It should have proper fitting. Otherwise what happens? It may lead to overturn or it may slips out from the nut surfaces. During the slippage, what happens? It may bounce back. Again, it may fall back. If it fall back, nothing will happen. If it bounce back, my nose is gone. So these are the operator fatigues will be happening in case of tightening and loosening. So what we will do is, in order to give a proper contact, we will be establishing some of the angles. If I use a square bolt, have you seen square bolt anywhere? Yes, there are several square bolts. If I want to tighten a square bolt using a spanner, the angle of contact will be 45 degree. 360 by 4, it is 45 degree. If I give hexagon, the angle of contact is 60 degree. If I use octagon, again the angle of contact will be reduced. So hexagon is having 360 by 6, 60 degree, so 30 degree, it is the angle. Square 45, it is 90 degree. 360 by 4 is 90 degree. And octagon 45 degree. So comparing these three, hexagon will have less angle of contact and more gripping will be there for hexagonal bolts. That's why in the manufacturing, most of the bolts are hexagonal headed bolts. For a square, 90 degree, again contact is less. Because of that, what happens? It may slip back. So compared to square and hexagon, you require more tightening in square. And octagon, yes, again, more slippage. Hexagon will having 30 degree, angle of contact is less. Octagon is having 45 degree, square is having 90 degree. Because of that, what happens? The slippage will be more or less. The slippage is depending upon these angles. And you can easily tighten hexagon rather than square because it is having less angle 30 degree, so that it can fit more 30, 30, 36 sides. It is flexible to fix a spanner. Whereas this square having only 4 heads, it is not so flexible to have a grip. Hexagonal, it is having 6 edges. It is easy to have a grip. Then these are the standards we will be using, and the standards for this is BS IS 1364 to 2002. These are the standards Bureau of Indian Standards will be using in order to nomenclature, in order to give the naming, in order to define the relations for the bolt and nut. So you have to just remember 3 things. One is what is bolt, what is nut, and what is stud. Bolt is a cylindrical structure having external threads as well as a shape. Nut is a hollow prisms which is having internal thread. Stud is a cylindrical structure having threads on either sides, and it is not having any head. These 3 things you have to remember: bolt, nut, and stud. Even washer are the cylindrical surfaces. They will be given in order to reduce the wear and tear of the bolt and nut. So this is a washer. The thickness of the washer is almost small. And let us see how to draw a bolt and nut. How to draw a bolt and nut for a different cases. So these are the proportions you have to know. There are again 2 components. One is bolt and another one is nut. For the bolt, these are the specification. For the nut, these are the specifications. If I take a bolt is having the length and dia. Generally, the diameter is given. The diameter of the bolt is given. And even in some cases, the length is also given. If length is not given, you can assume. Diameter and length is given. This D is major dia or nominal dia of the bolt. Let us see what are the different correlations which are used. Number 1, bolt head thickness. The thickness of the bolt head, how much hexagon head. So that should be T is equal to 0.8 D we will be using. This is the relation, and this varies from 0.8 D to 0.8 D to 1 D diameter. So generally T is equal to small t 0.8 D, that is the convention we will be using. Then nut thickness. What is the thickness of the nut? The nut, always remember, the thickness of the nut should be slightly greater than the thickness of the head of the bolt. So if you are using 0.8 D for bolt head, increase some thickness to nut. It is 0.9 D. If you are using lock nut, that should be less than the head thickness. If you are using lock nut, that should be less than bolt head thickness. Okay. Nut thickness should be more than head. Remember that. Then root diameter. What is this root diameter? At the end, there is a root. So for this, we will give some chamfer in order to have a proper fitting. That diameter should be 0.9 D. It is a root diameter, or in the previous class we have seen what is the root. the same thing. The diameter corresponding to that is root diameter. Then the thread length. How much thread has to be given? The thread length are having two things. One is, if it is less than 150, it is 2D plus 6 mm. It is greater than 150, it is 2D plus 12 mm. Again, see the length. If the length is less than 120, 2D plus 6. If the length is greater than 150, 2D plus 12. And why plus 6 plus 12? These are the geometrical dimensions and tolerances they have given. GD and T conventions. That dimensions will be following. Sir, can I change this? No, you cannot change this because this is international standard. And width. What is the width? Which width? What is this width here? Here the width is hexagonal width or square width. So it is having an hexagon. This is a hexagon and this is a square. Again, there are two things. When I place hexagon like this is a hexagon placed at a corner. So the width across the corner is 2D. I will be mentioning that width across corner. Corner to corner distance. Corner to corner distance. And most of you have a doubt here. When you want to construct a hexagon of side 30 mm, what is the radius you will be taking? The radius you will be taking is 30 mm. Suppose I want to construct a hexagon in the flat position or in the side position. If I take hexagon at 30, you won't get easily because the corner distance will be not equal to side distance. That is very important. So this is a corner to corner distance. Again in square also you have a corner to corner distance. Then across flats, side to side distance. What is the side to side distance of hexagon? This is a side. This is side to side distance W flat. Again side to side distance for the square, width of the flat. So side to side distance, width of the flat, corner to corner distance, width across the corner. Very important thing. If you change this, you gone. Always remember one of the condition. You need not remember both the conditions, remember one of the conditions. Easy to remember is, if the bolt diameter is having D, then the width of hexagon should be 2D from corner to corner. Got it? If the bolt diameter is having D, then the corner to corner distance of hexagon should be 2D. That is very important. Whenever we take an assembly drawings, this point is 100% essential. Very important. Then the chamfer. What is a chamfer? Yes, we need to have a smooth edges. Because of that, what happens? There might be wear and tear for the operator if we holds or if we tights or if we loosen it, anything. So for that we will give chamfer. Again chamfer for two things. One is bolt head, that is for 30 degree, and bolt end, that is for 0.1 D into 45 degree. And you have a different types of problems here. Generally, they can have any combination, they can ask any combination. The first, what you have to know is it only bolt and nut or bolt and nut with washer? Most of the cases, I will always take a complex situations, bolt, nut along with washer. Bolt, nut along with washer. Sometimes lock nut. Sometimes lock nut. So lock nut is not so asked in the examination, but I will solve one problem with lock nut, but bolt, nut and washer is very important. Bolt, nut and washer. Again there are two conditions. One is if you are placing on corner, and another one is if you are placing on side. Just two conditions you have to know. One is you are placing on corner, one you are placing on side. Corner, this is a condition, side, this is a condition. Then if you place on corner, again there are two things. They can have square and hexagon. Again here also square and hexagon. What is the important thing here? If it is a hexagon, how many sides are visible in front view? How many faces are visible in front view? If you are placing hexagon on corner, this is a side view, this is a side view. And how many faces are visible in the top view? Look here, this is a first face, phase 1, phase 2, phase 3. 3 faces are visible in the top front view. By looking at this, you can write, see here, this face is visible, this face is visible, and this face is visible. 3 faces are visible. If you are looking from top, again 2 faces are visible. That's all. If you are writing hexagon in front view, you have to write 3 face. If you are writing hexagon in top view, 2 face. Similarly for square, how many faces are visible? If you place square on corner, this is a condition. How many faces are visible? Only 2 faces. 2 faces are visible in the front view, and only 1 face is visible. Sorry, again 2 faces are visible in the top view. In both the views, front view and side view, front view and top view, 2 faces are visible. I will transfer top view like this. Again here, if I place hexagon on side, this is a side. In front view, only 1 face is visible. Again in the top view, 1 face is visible. This you have to know. If I place hexagon in side, this is a condition. 2 faces are visible in top view. Front view, 3 faces are visible in top view. These things you will be knowing. Again, I will be repeating frequently these things. Just the problems are, one you are placing on corner, one you are placing on side. 1, 2 problems, again 2 problems. So totally you have to study around 6 problems. Sir, why 6 problems? With washer. Bolt and nut in these 2 conditions, and bolt and nut and washer in these 2 conditions. They can ask anything. First you have to identify whether the bolt is placed in corner or side. And whether you have to identify, next thing you have to identify square or hexagon. That's all. That completes the analysis part. So, in the problem sometimes they will not mention, draw the 2 views of bolt and nut. Just they will ask with washer assembly. In that cases, you can write hexagon or you can write square. You can place it in corner or you can place it inside. Your choice, your wish. So, preferably if they ask like that, you use square. Don't make the things complicated, because you have to complete this within 15 minutes. Management of time is very important in machine drawing. So in that cases, directly write a square which is placed on the side and finish the views. If they ask 2 views, don't make complicated. Just write side view and front view. That's all. Side view and front view. Don't write top view also. It is a time consumption. Side view hexagon you can construct, project it, directly write the front view. So you have to make simplifications of drawing. This you can understand only with repeated examples. So in the next class we will solve some of the problems on threaded fasteners. Thank you.